We'll get started. So my name is Stephen Rees-Carter, and today we're going to have a look at same-site cookies, what they are and why they matter, and why as developers, as web developers, we need to know what they are and need to be aware of them when we're building our applications. So come on, turn the page, thank you. So same-site cookies started out as a proposal for a cookie attribute called first party. And it was proposed in October 2014 by Google. And the idea was to mitigate the risk of cross-site request forgery. And so it would specify a cookie and when it could actually be used and when it could be sent on request. So only on first-party requests, as the name suggested. So it's first called first party, and it was a simple attribute that was added to the cookie in the same way that the HTTP only attribute is added or a secure attribute is added. We just add it onto the cookie and there's no value set. So after that, after they first named it, proposed it as first party cookie, they changed the name to first party only in February 2015 to make it a little bit more clearer as to what the purpose of the cookie was. And then in January 2016, it got renamed to SameSite. I'm assuming to move away from the naming system of first party and third party over to SameSite and crosssite, which matches more with cross-site request forgery and is a bit clearer as to what it's dealing with, site as opposed to parties. So that was in January 2016 when it was changed to SameSite, but it was still only an attribute that was added. There was no value at all added on there. So there was no way to define the specific behavior in the use case that you're using it for. And so in April 2016, they proposed 3 values were set on the SameSite cookie attribute. So you got strict, lax, and none. And these 3 define the behavior of the cookie depending on the different scenarios that you might need to use it in, and then make it much more flexible and much more usable. So that was proposed in April 2016. And then in May 2016, Google Chrome 51 added support for it. So it was rolled out to the internet where you could add the SameSite cookie attribute to your cookies. And Google Chrome would acknowledge it, would follow it, and would attach cookies following the rules that it specified. So that was in May 2016. So it's been around for quite a number of years. But the question is, what is the purpose? What problem is it trying to solve? And before we dive too deeply into how it works, we need to understand what cross-site request forgery attacks are, CSRF attacks. Because if we don't understand that, if we don't understand the purpose of the cookie and what it's trying to defend against, then understanding the rules and why they're there, it's a lot harder to do. So in a nutshell, a cross-site request forgery is attacking this sort of request, this sort of transaction. So if you're a user and you wish to update your password on a website, you would make something like a post request to mysite.com/account, and you would send the password as a value on that request. So when that request comes through to the server sees it, and it acknowledges the user and it checks the cookies the user is providing, and it says this user has been authenticated, and then it changes the user's password. And so when the request goes through, the user's password gets updated to the correct password on that post request. But the problem is, if you don't have any CSRF protection on this request, then a hacker can hijack it. So if you as the evil hacker can trick a user into visiting your site, so say anothersite.com, if you can get the user to go here, then you have control of the user's browser. And if you can run JavaScript in the user's browser, which you can do if they visit your site, then you can cause the user's browser to make requests that you want, and you can send forged requests. So in this example, the user visits anothersite.com, which runs JavaScript, which makes a post request to mysite.com/account, and that includes a different password. And now the server receives this request from the user, the post request to mysite.com/account with the different password. And the browser has helpfully added the user's cookies on there because it knows mysite.com. And it says, okay, this is a request to mysite.com. I know this site. I have cookies, and it attaches the cookies. So the request hits mysite.com. Mysite.com says, fantastic. I'm going to update the password because you've told me so. I can read your cookies. I know that you're a user. It's all good. But what's happened is the evil hacker has now updated the user's password. The user has no idea this has happened. They have no visibility. They might not even notice for months, weeks, years, because it's all happened when they visited anothersite.com, and it was done in the background. And the server had no way of knowing this was a forged request, because as far as they were concerned, it was a legitimate request. It had a cookie and everything. It had the authentication cookie. So how is it supposed to know that it wasn't supposed to change the user's password? And that's where CSRF protection comes in. So traditionally, we would use something like a CSRF token. And the way that works is you generate the secret, the token, on the server, and you attach it to all the requests that are going out to the browser. So the browser has the token in the form, and when the user submits the password change form, it includes the token and it sends it back to the server. And when the server receives the request, it checks the CSRF token that it received from the request against the one that it knows that it sent to the browser in the first place. And if the token is invalid, if it doesn't match, if it's not there, then it will reject the request. And the reason this works is the browser security settings say that you can make external requests, you can make cross-site requests, you can send data to a different site, so you can send data from another site.com to mysite.com, but you cannot read the result, you cannot read the response. So there's no way for another site.com to get the CSRF token because the browser won't let it. The browser lets it send the request and the server will respond, but the browser won't let the JavaScript read the response, and so it won't get the token. And so you cannot steal a CSRF token using that method, which is why CSRF tokens are used to protect from this sort of attack. Now, another option you could use is to check the origin or the referrer header, because browser security settings, similar to the CSRF token, browser security settings prevent you from modifying these on request. So you cannot send a forged request and change the origin or the referrer header. And so the server can check these values, and if it knows what to expect, if it can expect a specific origin or referrer value, then you can check that because you can trust the value is coming from the browser and not the attacker's JavaScript. Now, the third option that you can use if you can't use a CSRF token or nonce or the origin or referrer header is to use some form of client-side cryptographic magic. And some applications, you just can't use a CSRF token. You can't set the headers. You have to do something else. And so you have a proof of work or some keys or something like that. The point is that the attacker cannot replicate, cannot fake or forge the cryptographic magic. And so when the request hits the server, it knows that it's a forged request because you were unable to forge that magic or forge that request. But there is also a fourth option, as you probably saw coming, is the SameSite cookies. And you can use that to prevent these requests, prevent these attacks as well. So SameSite cookies are added onto a cookie, as I explained before, by just on the end, the same way that you would add secure at HTTP only. And so you've got the cookie value there, you've got set cookie, then you've got the cookie value, then there's semicolon, then you've got SameSite equals strict or none or lax. And that's all it is. You're just adding the attribute, adding that extra information onto the cookie to tell it the behavior that is required of the browser when the cookie is being used. So can you use SameSite? Is it safe to use? Is it supported? And it's pretty widely supported across all the major browsers. There's a couple of interesting things with IE and some Safari things, but that's being resolved. And everything else, it works fine, except for Opera Mini. I'm not sure who actually uses that anymore. So it's pretty safe to use. And yeah, there's no downsides to implementing it on your site. Then you'll just add to your security, add to the strength of your cookies. So SameSiteStrict is the most secure, the most strict option. And it says that cookies that are marked as SameSiteStrict can never be sent on any cross-site requests. So that means embedded content such as iframes and images, it's not sent. Unsafe requests such as post, put, and delete, they're not sent. Even safe requests, so GET requests and head requests, it's not going to send the cookie. So if your browser is making a request from another site.com to mysite.com, the cookie is never going to be sent, which means it blocks all CSRF attacks when the cookies are required because the cookies are never sent. And so the authentication cookie that the server is expecting won't be received, won't get there. The downside of this is that, and you may have picked this up already, the GET request. So if you're on twitter.com and you click on a link that goes to mysite.com, the first request you go there, if the cookie is set to SameSiteStrict, won't have the cookie. So if your users are expecting to click on a link and go to your site and be logged in, they won't be logged in. The cookie won't be sent. Now, as soon as they do anything else, they make one more request, one more click on a link inside your site, that's considered a SameSite request, and suddenly the cookie is attached, and magically the users are logged in, which can be really, really confusing and really strange for a user who can't quite understand why when they first hit the site, they're not logged in, and they go to click on the login link and suddenly they're logged in. That's just weird. And so you need to be careful with strict that you only use it in situations where the first request doesn't need to be logged in because the cookies won't be sent. Now, the other end of the spectrum from strict is SameSiteNone. And none says we want to send the cookies on every single request. So that means send them on embedded content, send them on unsafe requests, send them on safe requests. Just send the cookie on every single request. And that is the current behavior that cookies have when it's not set in most browsers. I'll get to that shortly, is that the cookie is always sent. Now, there is an exception with SameSiteNone as part of the browser's efforts to make the internet more secure and more private and raise the security and encourage websites to use HTTPS. They're actually requiring the secure flag to be set on SameSiteNone. So if you set a cookie with SameSiteNone and the cookie doesn't have the secure flag, or it's not accessed over HTTPS, then it's considered an invalid cookie and it's not going to be sent. So you need to have the secure flag in order to use SameSiteNone, and it has to be done over HTTPS. So as you would expect, SameSiteNone doesn't block any CSRF attacks because it always sends the cookie. And so if you need to use SameSiteNone, you need to have CSRF protection in place to protect those requests and protect those actions, because SameSiteNone isn't going to protect you for it. So as I said, SameSiteNone, if you don't send secure, it won't be sent. And so it's considered an invalid cookie and it will be dropped. It just won't be sent on any request. And so there's no point setting it. Now, the happy middle ground between none and secure, is Lax. And Lax says that we will only allow safe requests to have cookies. So embedded content such as iframes images, no, there are no cookies allowed on those ones. Unsafe requests, post, put, delete, etc., no cookies allowed. But you do want them on get and head. And this goes back to our scenario where you're on, say, twitter.com and you click on mysite.com. When the user makes that GET request, that cross-site GET request from twitter.com to mysite.com, the cookies will be added because SameSite Lax allows the cookies to be added. Therefore, the users will be logged in when they hit the site and there'll be no confusion. And so Lax is a nice, happy, sane default and sane medium between the two extremes, because in general, when people are clicking through the internet, clicking on GET requests, they want their cookies to load them up and log them in, but they want to be protected from CSRF attacks and other such things, such as embedded content. You can have clickjacking attacks, for example. And so SameSite Lax will protect against those. Now, SameSite Lax, as you would expect, protects against CSRF attacks, but only on unsafe requests and embedded content. So it won't protect against a CSRF attack if it can be executed over a safe request, so over a GET request. So time for a little story. So at the start of this year, which was a long time ago, as I'm sure we'll all agree, I was preparing for a talk at WordCamp Asia. And part of that talk, so the talk was a live hacking demo of hacking into WordPress, where I demonstrate various different vulnerabilities in in plugins and bad dodgy coding, that sort of things, in older versions of WordPress, and demonstrating various vulnerabilities and how you handle those and how you mitigate them. And one such vulnerability is a nice little CSRF attack where you can upload a PHP file onto the server. So I was practicing my talk and I had done it quite successfully in August last year at a conference. And so I was running through everything, making sure it was all working. I didn't expect anything to be wrong. And I got to my CSRF attack and it didn't work. It just failed. The file didn't get uploaded at all. And it was really weird. And I was trying to work out what was going on. And then I checked the browser console and I saw this message. A cookie associated with a cross-site resource was set without the SameSite attribute. It has been blocked, as Chrome now only delivers cookies with cross-site requests if they are set with SameSiteNone as secure. And suddenly it all made sense. Suddenly I remembered what was going on. So back in May last year, Google announced that they were working to improve privacy and security on the internet. And part of that was to use the SameSite cookie attribute in order to make requests more secure and mitigate common vulnerabilities and attacks such as CSRF attacks. So they were talking about defaulting SameSite to Lax in order to make most requests a lot more secure and lock down things. And in October last year, they reiterated it and provided details, and they announced they would be setting SameSite Lax by default on all cookies that didn't have a SameSite attribute set. And they would also be enforcing secure on SameSiteNone. And they announced this in October last year, and they said it was going to come out in Chrome 80 in February. That was when they were going to start rolling out this SameSite Lax by default to all users. So if you're doing the maths and you're working out, remembering the dates I mentioned, I was testing my code in January and this was coming out in Feb. But there were these flags. So in October last year, when Google announced this and was making a big noise about these changes they were implementing, a bunch of bloggers and security experts such as Troy Hart and Scott Helm we're blogging about this and talking about how you can test it out now. And if you go into the Chrome, you can enable these flags, and then it would enable SameSite Lax by default early. And so you could test it out and make sure that all your sites are working. And I did that back in October last year, I think it was. I turned these on. And there were a couple of weeks where Google Hangouts wasn't working, which was quite entertaining that Google hadn't got that right. And the ATO website had a weird payment issue. But apart from that, nothing else broke. And so I completely forgot about it. Then when I was preparing my talk in January, it just wasn't working because I had those set. And that was the reason why my demo was busted even before they'd done the rollout, was because I had manually enabled SameSite Lax by default. And it was working perfectly. It was doing its exact job. It was protecting the user from a CSRF attack on this site. So even though the website was vulnerable, my browser, Chrome, was blocking the attack. It was protecting me as a user from the attack that the evil hacker was trying to commit. So in Feb this year, sorry, one sec. In Feb this year, Google reiterated they were starting to roll out the change in Chrome 80 to let everyone know. And so they started rolling out the change and started rolling out SameSite Lax by default to Chrome. However, COVID hit, and Google realized in April, or probably lead up to April, I'm not sure exactly when they had this realization, but they announced in April they would be rolling back SameSite Lax by default because everyone was moving to working from home. And when you're dealing with a lot of users that are moving from an office to working from home, especially those in large enterprises and corporations where they've got tens, hundreds, maybe even thousands of different systems that all tie together in some very, very carefully constructed chaos, rolling out a change like SameSite Lax that could break cookies in weird and unexpected ways could be a huge problem. And you could break an entire company's internal systems by blocking their cookies inadvertently. And so Google decided to roll back SameSite Lax by default and allow everyone to transition to home and have a stable internet. And it wasn't just SameSite Lax by default. There was a bunch of different things that Chrome and Microsoft and a few other of the big companies said they were going to do, and they slowed down updates and things for the purpose of making the internet a little bit more stable. And so Chrome announced in April that they were rolling back that, and they would, in the future at some point, reintroduce SameSite Lax by default once they felt it was the right point. So May 28th of this year, I did a talk very similar to this at Laracon EU. And as part of the talk, I mentioned that Google paused the rollout and they haven't announced yet when they were going to do the rollout. So I did the talk in the evening of that night, and then I woke up in the morning to this tweet. And what do you know, Google announced a few hours after my talk that they were going to re-enable Lax by default, the rollout, in July in Chrome 84. So I thought the timing of that was quite hilarious, that they announced to restart the rollout after I'd just done a talk saying that they hadn't announced it yet. So that was quite funny. So that was in July this year, and they started the rollout. And in August this year, they finished it. And so now since August, Google Chrome has been defaulting to SameSite equals Lax by default for all cookies that don't have SameSite set. And the fact that probably there's a few of you that haven't heard of this before, and it hasn't been a big thing. It hasn't really gone around the internet as Google have broken the internet and they've made these changes and you need to fix these things, tells me that SameSite Lax is a good, sane default, because it allows the requests that need cookies to operate normally, the GET requests, but it blocks the requests that have CSRF attacks and other such things as common. So it makes the internet safer, but it hasn't made it less stable and hasn't broken a whole bunch of stuff. So that's really good. But this isn't the end of the story. So when Google announced SameSite Lax by default, a bunch of companies went away and thought about how it was going to affect their things. And Microsoft came back to Google and said, wait a sec, this is going to break things. Because they realized that as part of the OpenID Connect authentication flow that Azure Active Directory and Microsoft account uses, it was going to break the flow. So the way that flow works is the user clicks the login on mysite.com, and that sets a CSRF token in a cookie, and it redirects the user to auth.com. So the user's browser visits auth.com, the user authenticates and does the single sign-on there. And then that redirects the user back to mysite.com as a post request with the completed authentication tokens. Now, when you have SameSite Lax in there as well, that post request going back to mysite.com comes from auth.com. That's considered a cross-site request. And the browser says, no cookies, thank you. And so it doesn't attach the CSRF token cookie. So when the request gets back to mysite.com, the cookie is missing because the browser has blocked it. And the server, the mysite.com, says, where's your cookie? You're not a legitimate request, go away. And so the authentication fails. And that's a big problem. This isn't just a case of Microsoft updating their code and rolling it out to their fleet. This is code that is implemented in user systems, in enterprise systems, in any systems implementing this flow. And it's written up in all the example documentation and example code and all those different places. And so it's very, very hard to quickly make a change to this. There are a lot of developers that don't keep an eye on these sorts of things. A lot of systems that have been built by contractors that don't have active development. And this was a big problem. I don't know exactly how many sites would have had this thing, but this would be quite a common problem, not just across the OpenID Connect, but a bunch of others. I'm sure this is a very common pattern, redirecting around using a post request to send tokens, that sort of thing. And so Google thought about, how do we solve this problem? How do we allow this to work? Because they don't want this to break. This is going to cause a big problem if they break half the internet because they've blocked this, because SameSite Lax by default blocks this. And they came up with a thing called Lax plus Post. So SameSite Lax plus Post is set when the cookie is missing the SameSite attribute, and it allows safe requests through the Lax, but it also allows any cookie that was created less than 2 minutes ago. So if you have a cookie, so if you set your cookie and then you redirect somewhere, and then that redirects back within 2 minutes, then the cookie is allowed and the cookie is sent, and so the authentication is allowed to continue, and the flow works and it solves the problem. Now this is only a temporary solution. I don't know when Chrome are going to disable Lax plus Post. Maybe in 2 hours they're going to announce that they're disabling it, if they follow the pattern from my last talk. But I don't know when it's going to happen. But the point is that this gives more time, so it allows them to push out SameSite Lax by default now, but it gives more time for all the enterprise systems that can't instantly support it, which is quite good. So that's Lax plus Post, and we'll have a look in the demo at that behavior in practice. So what is a SameSite domain? Because I was setting up a test, I was trying to set up a demo of SameSite and cross-site requests. And when I first set it up, I did a bunch of subdomains on one of my domains because it was the easiest option to provision. And the cookies were always attached. Even when I was setting SameSiteStrict, it was still attaching the cookie. And I realized that SameSite means SameSite on the root, so it allows subdomains. So mysite.com is considered the same site as static.mysite.com and account.mysite.com. They're all considered the same site. But what about something like github.io, which is a public domain? Well, I guess public domain in the sense that you can get a subdomain off it. Do we really want cookies to be able to be sent across those different subdomains? And that's where the public suffix list comes in. So it's a list of domains that are used for public subdomains like this, like github.io. And it defines it as a cross-site domain. And so a request going from laravel.github.io to valoran.github.io is considered a cross-site request. And if you're using SameSiteStrict on that, it will be blocked because it's a cross-site request. And if your site, if your system, your company uses a domain that has public subdomains like this, then I would recommend checking out that list to get your domains added onto that list for added security. And I'm pretty sure there are a few other things, not just same-site domains, same-site cookies, I should say, that actually use that list. So that's quite an important thing, but it's the subtle difference between these two domains. So you've got the samesite.com versus github.io. And when you're trying to test things, it can be confusing if you're not aware of what sort of domain that is. So let's look at look at the browser and see this in action. I'll find the right tab. Cool. Okay, so this is my SameSite cookies tester. I will dump the link into the chat if I can get it working. There we go. And I might put it in Slack as well in case it's easier in there. Give me a sec. Okay, so that's now in Slack. So feel free to jump on that now if you're interested. It should work on any web browser, and you can use it to test the behavior of the cookies in your browser. So in this case, we're using Chrome. This is an updated version of Chrome, so it should have the latest behavior. So there are two features in here. We've got the manual tester and the automatic tester. So I'll boot up the automatic tester and I'll run it in the background, and we'll come back to that in a minute. Now we'll go into the manual. So when you view the manual tester, what it's going to do is it's going to set 5 cookies in the browser, at least attempt to set 5 cookies. I'll throw open the inspector, and we can see here we've got, where's that request? Oh, let's refresh. Didn't open that in time. Okay, so set. Now, can I get rid of, oh. Okay, to make this a little bit bigger. That thing up there's annoying. Oh, it doesn't matter. Okay, so get rid of those. And we can see down in here, response cookies. So these are the cookies that have been sent when this request came through from the server. So we've got the strict cookie here, which is set with SameSiteStrict. We've got lax cookie is set to lax. Secure none cookie is set to none, and it has the secure flag set. We've got default cookie, which doesn't have anything set. So there's no SameSite attribute set here at all, and secure isn't set on that one. And then we've got none, which has none set and secure isn't set. Now, immediately we're going to notice the yellow one at the bottom and a little pop-up thing, which is telling us that SameSiteNone was blocked because it doesn't have the secure attribute. So Chrome has rejected this cookie already when the server tried to set it, and it's not going to remember it. If we go up here and look at the request cookies, which is what we set from the previous time we loaded the page, we're missing the none cookie because it's not considered valid in Chrome. And so this is quite handy because you can see the different cookies and what's going on in here. That's under the inspector. You got network, then you click on the request. And you can also filter in Chrome has blocked cookies, and will only show you the requests that actually have blocked cookies, in which case this one down here, which is really helpful when you're debugging cookies and debugging behaviors to work out what's going on. You can also show and hide the filtered out cookies, the cookies that aren't sent, and these ones that are set from the automatic tester. So we'll get rid of those. But again, it's just some extra little helpers to make it easier for us to debug. And the last thing, if it's going to work, here we go. So if we jump into the console in the inspector and go view issues, which is a new pane that Google added, we can see here it's telling us about our cookie here. So the SameSiteNone cookie, and it's telling us it's missing secure. So it's telling us what the cookie is, what request it was, and it's giving us a link to a really helpful page explaining the behavior of this and what's going on. So this is quite helpful. And Chrome added this fairly recently, but it makes it a lot easier to debug what's going on with cookies in the browser. So I'm going to back over here. Now cookies is that let's actually use them. Let's see what's happening. So this is SameSiteTest.com. We'll go to an external site, which is SameSiteTest-external.com. This is a different site, a cross-site, and we're going to make a cross-site GET request. We'll jump over here. Oops, blocking cookies. Okay, cool. So go to the request. We're on the GET request now. So we've made a GET request, and as we can see here, strict wasn't sent because GET requests are blocked on strict cookies. Lax was sent. Secure none is sent because it's always sent, and default was sent because it's defaulted to lax. So, and none is invalid, so it's not there as well. So we can see the same cookies down here. So as we would expect, the GET request, if we set a lax cookie, it goes through, and so the user can be authenticated when they hit it. But if it's strict cookie, they're not going to be sent. It's not going to be sent. They're not going to be logged in. So jump back to the external site, and we'll make an iframe request this time. So this one is going to load up an iframe on SameSiteTest external, and this frame goes to SameSiteTest.com. And in here, we can see the only cookie that actually went through is the secure none, because it's the only cookie that is allowed to work on embedded requests, which is the iframe. And if we jump down in here, we can see the request here, and the cookie is in here, the one that went through. And if we click on the show filtered out, we can see we've got our other cookies, strict, lax, and default, and it's got them blocked. And the little info box here is telling us why it didn't go through. So this is Chrome helping us to debug why our cookies weren't sent, which is really, really helpful. And finally, we're going to check out our post request. So clicking on this one will make a cross-site post request. And again, we only have secure none sent, as you would expect. So again, we're protecting against a CSRF attack on the cross-site if we have lax set on that one. Okay, so that's the Chrome behavior in here for those three requests. And the automated tester that I ran before produces this output. So it spends a couple of minutes and it makes every possible combination of requests that I could think of to test the expected behavior of the cookies. So we can see at the top here, HTTP shared none. So shared means it's a same site request. And this is sending the cookie as same site none without the secure flag, and it was sent over HTTP, which is rejected because you cannot send a same site equals none cookie. This one is same site none secure, but it's HTTP, and it's rejected because you cannot send a secure cookie over HTTP. The next ones are all yes and all allowed because it's a same site request, and so lax works on same site, strict works on same site, Default and invalid are functionally equivalent. Default is when I'm not passing SameSite at all. And invalid is passing an invalid value and the browser is just forgetting about it. It's just pretending that you haven't set SameSite. So they're all allowed through because it's a SameSite request. This one is again blocked. We've got shared none because we've got SameSiteNone without secure, so it's immediately stopped. This one gets through, however, as opposed to up here, because it's an HTTPS request on non-secure, and so it gets through. And again, we've got those ones here. They're all shared HTTPS as we would expect. Now we get down to the no's. So this one's an invalid cookie. We've explained it before. That's an external, so a cross-site request. And then here we have a cross-site request on non-secure HTTP. It's blocked because it's HTTP. Here we have a HTTP external lax. The same site is lax on a cross-site request. It's blocking the iframe, it's blocking the image. It's allowing the GET request and it's blocking the post. That is what we expect to see there, this one here, because that is a SameSite Lax request on a GET, which is a safe request. We've got strict, it's blocked on everything because it's a cross-site request. And then these ones are allowed through because they don't have it set. And you'll notice the yes here is different to here. And here's the important bit that I'm testing. Here is the 2 minutes and 2 minutes. So we've got the first request is less than 2 minutes away, and this waits 2 minutes in the middle. And we can compare the value here with the value here. So this is SameSite Lax plus post defaulting on. So it's letting through these requests with Lax plus post because the cookie was created less than 2 minutes ago. We move over here, the cookie is now over 2 minutes old and it's now set to no. And so we're only getting the safe request through. And so that's the difference between these two. And it's the same down here. This is the HTTPS version. And so this is really important when you're dealing with the authentication flows we were talking about before. So and this is default Chrome behavior now. So we'll jump over to Firefox and we'll have a look and see what it does. So we'll jump over to our tester. Oops, and it's going to set, where's it hiding? In slightly less easy to read format here, we're setting your cookies, got the same cookies being sent. Default is missing one, you got lax, none, secure, none, and strict. And it looks like Firefox is actually letting none through because it hasn't added the restriction that you need secure or none yet. So we'll go to the external site, we'll make the GET request, and the only one blocked is strict. Because as far as Firefox is concerned, the none cookie is still valid. It doesn't need the secure flag set. And this isn't giving us much useful information because it's not setting the cookies. And default is sent, obviously, because it's allowed through. Firefox isn't defaulting to SameSite Lax by default. So that's considered a cookie that cookie doesn't have a SameSite, so it's always going to be sent. Anyone blocked is strict on the GET request. We go to the iframe and we load it up in here, and the iframe is blocking strict and lax, as we would expect, because it's an embedded request, embedded content, and lax blocks it and strict blocks it. Secure none doesn't because it doesn't block those things. None doesn't block it because it's allowed. It's a valid cookie attribute in Firefox, and it doesn't block those things. But default is also added because it's not defaulting to SameSite Lax, as I said. So we're getting that one through. So Firefox isn't currently protecting embedded requests like this from CSRF attacks or any other attacks. Then we can go to post, and we would get the same output here. We're blocking strict and lax, but not the other three because Firefox considers them valid and legitimate requests. So we can load up the the automated tester and let it do its thing, and we can see the difference between Firefox's handling to Chrome's handling. Now, the interesting thing I discovered when I was practicing this demo and looking at the different features is that incognito mode in Chrome is actually different, which I thought was really curious. So I'll just boot up that, run that in the background, and then we'll go to the manual test. So now it's sent our cookies, and we'll check the GET request first. This is what we expect to see. Lax and secure none and default are allowed on the GET request. I'll go to the iframe, and nothing is allowed. So really interestingly, Google Chrome in incognito mode actually blocks all cookies on iframes, which I find absolutely fascinating that it's doing that, which is different from the behavior when you're not in incognito mode. So if I jump over into the inspector in here and I open this one up, we can see here that they're all yellow. There's no cookies here that aren't yellow. And if we find our, which was it, secure none, there we go, the secure none cookie, which we would expect to be sent on this request in this frame because it's allowed in non-incognito mode Chrome, it's telling us that it's blocked due to user preferences. Now, I may have done something, I'm not sure, but I suspect, and I'm pretty sure what's happening here is that Google is adding extra protection, extra security to incognito mode. And so when you're in incognito mode, it doesn't want frames to be able to steal any information, to capture anything useful. And so it's blocking all cookies as a precaution. But if we go to the post request, it does work. So it's only on the embedded requests, such as the iframes, that it's actually kicking in and doing that. And something else interesting to show, actually, while we're here, is this isn't incognito mode specific, it's just from the GET request. So we clicked on here, and this was a cross-site request. We can see strict is blocked. If I click on this one, if I click on the URL and click enter, we're now making a same site request and something that's toggled over. So that's the second request. So if you've got strict set on your cookie and the user hits your site, the cookie won't be sent to first request. But as soon as they do anything else, in this case, I reloaded the page, suddenly it's the same site request and the cookie is added. So that's that little behavior in there. That's still running. Where's Firefox going? So Firefox is still running through the tester. And so in the middle of the test run, it actually waits for 2 minutes to ensure that the cookies expire after the Lax plus post window. And then it runs through and it does automated tests, changing the page. And it loads up the different frames and images as well, so it's testing them all. And it's measuring what cookies are actually coming through, checking the server to see what the server receives. And when this finishes, we'll have a look at it and compare it to Chrome, and we'll see the difference. Okay, so that is that. Jump that over here and open that one up there. Cool. Okay, so now over here we have Chrome, and here we have Firefox. And scoot that over a bit. Over we go away, thank you. Cool, so we can see a big difference between the default behavior of Chrome and Firefox. So for starters, we see this row is yes, this row is no. So as we looked at Firefox allows SameSiteNone without secure. They haven't implemented that yet. There's another row down here. Again, that's the same as SameSiteNone if that's secure. We keep going down, we've got a bunch of no's there and there's a bunch of yeses here. And that's because Firefox isn't defaulting to SameSite Lax by default for these values, and so it's allowing them through, while Chrome is blocking them. And you can see that, but Firefox is handling Lax and strict, it's just not handling anything else as we were talking about before. And you can run this on your phone, for example, and see what your phone browsers are doing, if they're enabling these cookies by default or not. Yeah. Okay. So back to slides. Now, the question that you have is, what option do you use? And for some things it's easy, some things it's less easy. But as a general rule, if you're looking at same site attribute, what you want to set, you want to use strict if the user doesn't need to be logged in, or if you need an action performed over a GET request. So when the user hits your site, if they don't have to have off cookie set, if they don't have to have their session set up, then you can look at strict because you don't need the cookies on those initial requests. Or if your application, for some reason, needs to perform actions over GET requests. And there could be a reason, I don't know about, but there could be a reason why you need to allow cookies sent on those GET requests. And in that case, you want to set SameSiteStrict on the cookie because it will protect it from an attack. Now, you can use none if you need to make cross-site requests, if you're post requests or embedded content. So say if you've got an authentication flow and you need to send tokens between here and there, between two different sites, and you need that to be over a post request. Or if you're embedding content and you're trying to, and you need to be logged in the frame on a different site to the the page that it's currently being loaded in. So there are some situations where you want none. But if you're going down the path of using none, then you need to make sure that you protect those actions, protect those requests using other methods, so CSRF tokens, etc. Now you can use nothing. You can just not put anything in there if you want. But you run the risk of unexpected behavior, of the site just randomly breaking or doing strange things. Strange things as in the cookie is attached or not in some, The point is that the browsers are slowly heading towards SameSite Lax by default. So Chrome's done it already, and Firefox and Edge have said they will do it. I'm not sure what Safari's up to. It's kind of the IE6 of the internet, so, who knows where it's up to, but I assume they will get to there eventually, maybe in 20 years. The point is that you don't want to set nothing because things can change. Now, the same default, as we've seen from Chrome rolling it out, is SameSite Lax by default. So SameSite Lax. Because if you set Lax, then the majority of requests are going to work fine. It's only if you're doing something strange that Lax is going to block the request. And in those cases, you know what option you need. You can set to strict or you set to none so that you can have the required behavior. So stick to Lax unless you need something specific. So does SameSite Lax by default solve the problem? Does it answer the CSRF problem? Does it make the internet safer by preventing CSRF attacks? And I asked the question, is CSRF dead now that browsers are going to use SameSite Lax by default? And I had a pen tester respond and say that even with SameSite Lax by default, in a lot of the work that they've done, they've found they can still send GET requests and perform actions. So developers have built their systems and they're accepting requests and GET requests to perform actions, not just POST requests, which is a big problem because SameSite Lax by default isn't protecting against a GET request. And if you think that your application is only responding to POST requests, but it's actually responding to both, you're not going to be protecting those GET requests because you don't think they're possible. And so it does leave your site open to attack. It leaves the site open to a CSRF attack if you don't have other protections in place. And so no, it's not going to solve the problem because there would be a lot of sites where GET requests can be used to bypass these protections. And that's where it comes down to us as developers to be aware of what we need to do for the SameSite Lax, what we need to set on our cookies and how we need to code our applications so that all our actions are only accessible via, post or put or delete. And that GET requests are safe and the GET requests don't make changes. And so we can ensure that our applications are secure and that our applications can take advantage of SameSite Lax, but it's not going to solve the problem because there'll always be some applications that aren't. And that's just the way that the internet works, unfortunately, with sites being built and developers not being aware of these things and cutting corners. So, kind of a depressing end, but that's the way it is. Ultimately, you can protect your sites and make your site secure using this attribute, and that's what's important. So thank you very much. I hope you learned something from this. Feel free to shout out with any questions, either directly in WebEx if you want, or in Slack or the chat for this, and I'll stick around for a little bit answering questions. You can feel free to email me, find me on Twitter if you want to follow anything up, or I've got some notes and links to the various different announcements from Google and such on my site there if you want to find those, and a copy of the slides as well.